डियर स्टूडेंट्स, डॉक्टर मोहम्मद जमल चुगताई लेक्चर नंबर 6 लेकर हाजिर है। पिछले लेक्चर में हमने वोल्टेज डिवाइडर से मुतल्लिक सादा तरीन मिसालें हल करना सीखी थी। आज के लेक्चर में हम थोड़ी सी कॉम्प्लेक्स मिसालों को देखेंगे। उसके अलावा करंट डिवाइडर रूल के बारे में भी नेटवर्क्स को सॉल्व करना सीखेंगे। वोल्टेज डिवाइडर के बारे में एक बात याद रखें कि अगर हम एक रजिस्टर के अक्रॉस कुछ वोल्टेज को कैलकुलेट कर लें तो दूसरी रजिस्टर के अक्रॉस वोल्टेज को कैलकुलेट करना निहायत आसान हो जाता है। बजाय इसके कि आप थ्रू आउट सारी प्रैक्टिस को दोबारा दोहराएं, उसमें सिर्फ ये करना पड़ेगा कि जो भी टोटल सोर्स वोल्टेज होगी उसमें से कैलकुलेट की गई एक रजिस्टर के अक्रॉस जो वोल्टेज होगी उसको सबट्रैक्ट कर देंगे तो दूसरे रजिस्टर के अक्रॉस वोल्टेज की वैल्यू हमें हासिल हो जाएगी। वोल्टेज डिवाइडर में आइए एक और मिसाल देखते हैं। For the resistive network shown, we want to calculate voltage across 12K resistance using voltage division rule. As we have a look onto this resistive network, we can see that a 6-volt battery is being connected to a network of resistances having 4 resistors. Now, looking into the given circuit, we can see that 4 kilo resistance is in parallel with 6-volt source. Therefore, source voltage will be dropped across it. That is, this 4 kilo ohm resistance will not be able to make any difference to the 6-volt source. Therefore, we can omit this resistance from the circuit. Hence, we redraw the circuit, and after the omission of this 4K resistance, the circuit will adopt the shape as shown in this figure. Now, we start working towards the resistive simplification method so that we end up with the simplest form of the network, and hence we can achieve our goal as desired into the actual question. Looking on to this simplified circuit, we can clearly see that the 12 kilo ohm resistance is in parallel to 6 kilo ohm resistance. Hence, using our information for resolving two parallel resistances, we can write 12K parallel to 6K is equal to 12K into 6K divided by 12K plus 6K. Solving this expression, we can have the resultant as 4 kilo ohm value. Now, once we have calculated the equivalent resistance of the two parallel resistances, which we have just mentioned having values of 12 kilo and 6K, we must replace these two resistances by the equivalent value we have just calculated, so that we can redraw the circuit and it will have the form as shown in this slide. Now, clearly we can see that the two resistances, that is the 2 kilo ohm value and the 4 kilo ohm value, have become in series to each other. And if we further carefully look onto this circuit, this is presenting a very simple form of voltage divider circuit. Hence, we can apply the voltage division rule to this network so that we can write the voltage across 4 kilo ohm resistance will be equal to 4K divided by 6K into 6 volts. Simplifying this, the voltage across the 4 kilo ohm value will be equal to 4 volts. Since 4K is the parallel combination of 6K and 12K, therefore, same voltage will be across 12K resistance, which was connected in the original circuit. Hence, we can say that the output voltage, that is the voltage across the 12 kilo ohm resistance, will be equal to also 4 volts. Let's take another example of a resistive network where we want to find the power absorbed by each element of the resistive network. The resistive network is shown in this slide. It consists of 2 current sources, whereas a voltage drop across one of the current sources is given as 20 volts, and we need to find the voltage drop across other elements or the resistances in the network. To start solving this problem, we begin from the left hand side of the circuit, and we can see that across 4 ampere independent current source, it is given that a voltage drop of 20 volt is existing. Hence, the power at 20 volt source will be equal to minus 20 into 4. This minus sign is due to the reason that we are starting from the common node of this circuit, and as we move from the bottom of the circuit, we encounter the negative sign as given in the original circuit. Therefore, multiplying 20 by 4, we will have power for 20 volt source will be equal to minus 80 watts. After completing this, we can see there is another resistive element having a value of 1.5 ohms. Hence, we write V 1.5, that is, this will be the voltage which will exist across the 1.5 ohm resistance. And because we can clearly see from the circuit that the 4 ampere independent current source is supplying the current to the 1.5 ohm resistance. Hence, very easily we can find out the voltage drop across 1.5 ohm. Using Ohm's law, we can write V 1.5 is equal to 4 into 1.5, that will be equal to 6 volts. Now we know that there exists a 6 volt value across 1.5 ohm resistance. Hence, very easily we can calculate the power which is being absorbed by the 1.5 ohm resistance. Therefore, using the power formula, we can write P 1.5 is equal to V subscript 1.5 square divided by the actual value of the resistive element, which is 1.5. Hence, simplifying, after putting the value of V 1.5, we have power subscript 1.5 equals 24 watts. After this calculation, we reach at 14 ohm resistance. Therefore, we can write the equation for 14 ohm resistance as V14 is equal to 20 minus V 1.5. Hence, we will have V14 is equal to 20 minus 6 equals 14 volts. If you carefully see this resistive network, we can see that the resistances having a value of 1.5 and 14 ohm are making a very simple voltage divider network. Therefore, once we know the voltage drop across the 14 ohm resistance, we can very easily work out the power absorbed by this element. Hence, we can write P subscript 14 is equal to 14 square divided by 14. That will be equal to 14 watts. Now, as we reach at 2 ohm resistance, we can see that the actual current, which was 4 ampere, that is being split into the two branches. Hence, we can calculate the current passing through the 2 ohm resistance by writing I subscript 2. That will be equal to V2 divided by 2. That will be equal to V 1.5 divided by 1.5 minus V 14 divided by 14. After putting the values for V 1.5 and V 14, we have 6 divided by 1.5 minus 14 divided by 14. Hence, the value of I2 will be equal to 3 amperes. Therefore, we can have the voltage drop across the 2 ohm resistance by simply using Ohm's law. Hence, we can write V2 is equal to 2 into 3. That will be equal to 6 volts. Once we have calculated the voltage across the 2 ohm element, we can easily calculate the power absorbed by this element. Therefore, we can write P2 is equal to 6 square divided by 2. That will be equal to 18 watts. Moving from 2 ohm element, we reach at 4 ohm element. Therefore, we can write V subscript 4 is equal to V14 minus V2. That will be equal to 14 minus 6 equals 8 volts. Now, 8 volts is the voltage drop across the 4 ohm resistance. Hence, once again, we can calculate the power absorbed by this element. Therefore, we write P4 is equal to 8 square divided by 4. That will be equal to 16 watts. After calculating this power absorbed by 4 ohm element, we reach at a resistance having a value of 2.5 ohms. Before we can calculate the power absorbed by this element, we must calculate the current passing through this element, because this is an extra branch from the rest of the circuit. Hence, we can write I subscript 2.5 equals V subscript 2.5 divided by 2.5. That will be equal to V2 divided by 2 minus V4 divided by 4. Putting appropriate values into this equation, we can have I 2.5 equals 3 minus 2, that will be equal to 1 ampere. That means that 1 ampere is the quantity of the current which is passing through the 2.5 ohm resistance element. Therefore, applying Ohm's law, we can calculate the voltage across 2.5 ohm resistance as well. Hence, we write V 2.5 is equal to 2.5 into 1. That will be equal to 2.5 volts. Once we have calculated this voltage across 2.5 element, we can easily calculate the power absorbed by this element as well. Hence, we can write P 2.5 equals 2.5 square divided by 2.5. That will be equal to 2.5 watts. Once again, figure shows two resistances having a value of 9 kilo ohms and 3 kilo ohms are attached with the voltage source having a potential difference value of 12 volts. Now, using the same standard formula for voltage divider relationship, we can calculate the voltage drop across 9 kilo ohm resistance, which will be V1 is equal to 9, because we are going to calculate the voltage across 9 kilo ohm value. Therefore, 9 is on the top, divided by the total resistance of the voltage divider, which is 9 plus 3, into the value of the voltage source. Therefore, the value of V1 will be equal to 9 volts. Now, we can calculate the voltage drop across 3 kilo ohm resistance using the same technique, so that we can have V2 is equal to 3 divided by 12 into 12, which is the value of the voltage source, and we end up with 3 volts. इस मिसाल से हम देख सकते हैं कि जैसा कि हमने 9 किलो ओम रेजिस्टेंस के अक्रॉस वोल्टेज कैलकुलेट की, तो वो 9 वोल्ट थी. चूंकि सोर्स की वैल्यू 12 वोल्ट्स है, तो 12 minus 9 is equal to 3 volts, and that is the same value which we have calculated across the 3 kilo ohm value. अजीज तलबा, ये वही बात है जो अभी चंद लम्हे पहले मैंने आपको बताई थी कि बजाय इसके कि दूसरी वैल्यू के क्रॉस वोल्टेज कैलकुलेट करने के लिए मैथमेटिकल ऑपरेशन किया जाए, हम बिल्कुल सादा तरीके से भी वैल्यू निकाल सकते हैं. आइए वोल्टेज डिवाइडर की ही एक जरा थोड़ी सी और कॉम्प्लिकेटेड मिसाल लेते हैं. स्लाइड शोज देयर आर 3 रेजिस्टेंसेस which are connected in series, and we want to calculate the voltage drop across each resistor. It will be calculated as the value of first resistor is 50 kilo ohms. Therefore, using the voltage divider formula, we can have the voltage value across 50 kilo ohm resistor as V is equal to 50K divided by 100K into 200, because the voltage source is bearing a value of 200 volts. Therefore, the voltage across 50 kilo ohm resistance will be equal to 100 volts. Now, we can also calculate the voltage drop across 30K value. Similarly, we can use the standard formula, that will be V is equal to Now, because we are going to calculate the value across the 30 kilo ohm value, therefore 30 will be on the top divided by the total overall resistance value, which is 100, into 200, which is the value of the voltage source. Therefore, V comes up is as 60 volts, and this is the value which will be seen across the 30 kilo ohm resistance. Now, final and last resistance value, which is 20 kilo ohm, we can calculate using the formula, or otherwise we can calculate as well using the simple mathematical equation as we have described in the previous example. Now, V is equal to, because we are going to calculate the voltage across the 20 kilo ohm value, therefore 20 is on the top, so that 20 divided by 100 into 200, and we comes up at V is equal to 40 volts. अजीज तलबा, इससे अगली मिसाल में थोड़ा सा मजीद कॉम्प्लिकेटेड सर्किट देखा जाएगा, जिसमें वोल्टेज डिवाइडर सीरीज भी होगा और वोल्टेज डिवाइडर इन पैरेलल भी होगा. आइए देखते हैं. स्लाइड शोज अ 10 volt battery is supplying the power to a resistive network which is having certain values inserted in parallel and in series. As we studied in the last lecture, same voltage appears across the parallel resistances. दो resistances जो कि parallel में लगी हुई हैं, जिनकी वैल्यू 10 किलो ओम और 1 किलो ओम है, इनके अक्रॉस सेम पोटेंशियल डिफरेंस जो कि बैटरी सप्लाई कर रही है वही अपीयर होगा, यानी कि इस पर्टिकुलर केस में 10 वोल्ट की वैल्यू इनके अक्रॉस मेजर की जा सकती है. लिहाजा हम पहले 10 किलो ओम को ओमिट कर देते हैं और अपने वोल्टेज सोर्स को फर्दर आगे मूव कर देते हैं. जैसा कि इस स्लाइड में दिखाया गया है कि 10 किलो ओम के रेजिस्टेंस को हटा दिया गया है और अब चूंकि 1 किलो ओम भी वोल्टेज सोर्स के बिल्कुल पैरेलल में लगा हुआ है, देयरफॉर इसको भी हटा सकते हैं और 10 वोल्ट की बैटरी को अटैच कर देंगे हम 4 किलो ओम के रेजिस्टेंस से. Now we can see that the resistive network has become extremely easy, and it is really in the form of a simple voltage divider configuration. Now we can calculate the voltage across the 4 kilo ohm value. Therefore, because we are going to calculate across 4 kilo ohm value, we can write V is equal to 4 divided by the total resistance value, which is 8, into the potential difference value, which is being supplied by the source, that will be equal to 5 volts. Two voltage drops in series, जैसा कि मैंने पहले आपको बताया कि एक रेजिस्टेंस के अक्रॉस वोल्टेज निकाल के बआसानी दूसरे रेजिस्टेंस के अक्रॉस वोल्टेज को निकाला जा सकता है. आइए इसी को थोड़ा फॉर्मल तरीके से देखते हैं. Two voltage drops in series. For this case, it is not necessary to calculate both voltages. After finding one voltage value, we can subtract it from Vt to find the other value. As an example, assume Vt is 48 volts across two series resistances R1 and R2. If V1 is 18 volts, then V2 must be 48 minus 18 is equal to 30 volts. अजीज तलबा, इससे अगला टॉपिक करंट डिवाइडर के बारे में है. करंट डिवाइडर में दो या उससे ज्यादा रेजिस्टेंसेस को पैरेलल में इंसर्ट किया जाता है। और करंट डिवाइडर की बड़ी खूबी ये है कि किसी ब्रांच में अगर वोल्टेज ना भी मालूम हो तो फिर भी हम उस ब्रांच में से करंट को कैलकुलेट कर सकते हैं। आइए स्लाइड पर देखें। इट इज ऑफ्टन नेसेसरी टू फाइंड इंडिविजुअल ब्रांच करंट्स इन ए सर्किट बट without knowing the value of branch voltage. This problem can be solved by using the fact that currents divide inversely as branch resistance. The formula will be I1 is equal to R2 over R1 plus R2 into IT. अब करंट डिवाइडर के सर्किट को कंसिडर करके हम उसकी मुख्तलिफ ब्रांचेस में करंट को कैलकुलेट करने के मुतल्लिक पढ़ेंगे। आइए स्लाइड पर एक एग्जांपल देखते हैं। वी वांट टू कैलकुलेट द करंट flowing through 4 ohms resistance so that we can write I is equal to 2 divided by 2 plus 4 into 3। जैसा कि आप नोट कर सकते हैं कि वोल्टेज डिवाइडर में जिस रेजिस्टेंस के अक्रॉस वोल्टेज को कैलकुलेट करना चाहते थे वो रेजिस्टेंस की वैल्यू टॉप पर आती थी, जबकि दोनों रेजिस्टेंसेस का मजमुआ बॉटम में होता था। अब करंट में थोड़ा सा उलट हिसाब है कि जिस रेजिस्टेंस में से करंट को कैलकुलेट करना होगा उसके ऑपोजिट वाला रेजिस्टर उसकी वैल्यू टॉप पर आएगी, जबकि बॉटम में मजमुआ ही रहेगा। और इस सब को हम करंट सोर्स की टोटल वैल्यू से मल्टीप्लाई कर रहे हैं। लिहाजा I is equal to 2 divided by 6 into 30. That will be equal to 10 amperes. Now, we can easily calculate the current through 2 ohm resistor. Therefore, we can write I is equal to 4 divided by 6, the total resistance, into 30, so that the current value through 2 ohm resistor will be equal to 20 amperes. अजीज तलबा, इस मिसाल में भी आपने देखा होगा कि दोनों रेजिस्टर्स में से फ्लो करने वाला करंट का मजमुआ सोर्स की करंट के बराबर है। इससे ये बात वाज़ेह हो जानी चाहिए कि किसी भी सर्किट में ना तो अंदर से कोई पावर यानी वोल्टेज या करंट जनरेट किया जा सकता है, बल्कि वही जो वैल्यू सोर्सेस के ऊपर होती है वही डिवाइड होती चली जाती है। आइए करंट डिवाइडर में ही एक और मिसाल को देखते हैं। द फिगर शोज दैट 2 रेजिस्टेंसेस हैविंग वैल्यूज ऑफ 2 किलो ओम्स एंड 3 किलो ओम्स, they are attached in series to the current source, whereas another 2 resistances having values 4 kilo ohm and 1 kilo ohm are attached to the current source in parallel. Now, keep remembering that whenever there are resistances in series, through all the resistances, same value of current will be flowing. So, in this case as well, we can say that the same 30 ampere current is flowing through series combination of 2K and 3K ohm. So, they are leaving no effect on the value of current. लिहाजा हम इन दोनों रेजिस्टेंसेस को ओमिट कर सकते हैं और हमारा करंट सोर्स इनके बाद तस्वर किया जा सकता है, so that the main resistive network adopts the value as shown in this slide. Now we can apply easily the current division rule. The current flowing through 1 kilo ohm resistance will be equal to I equals 4 divided by 4 plus 1 into 30. That will be equal to 24 amperes. इससे अगली मिसाल में थोड़ा सा मजीद कॉम्प्लिकेटेड सर्किट ड्रॉ किया गया है, जिसमें एक सीरीज रेजिस्टेंस, उसके बाद एक पैरेलल रेजिस्टेंस, then again another resistance in series and another one in parallel जोड़ा गया है. आइए उसको देखते हैं. We want to calculate the current through 4 kilo ohm resistance, which is right into the center of the circuit and is attached in parallel situation as compared to the current source. Now we can see from the circuit that the resistance value of 1 kilo ohm is attached in series to the current source. Therefore, we can say that all the value of current, which is 12 amperes in this case, is flowing through 1 kilo ohm resistance. Hence, we can move our current source ahead of 1 kilo ohm resistance. Now, the circuit will adopt the form as shown in this slide. Now, because the current source is facing two resistances, one in series and one in parallel, therefore, the current at node A will be divided into two parts. That is, one part will be flowing through the branch which is attached with 2 kilo ohm resistance, and another part of 12 ampere current will be flowing through the branch which is marked as 4 kilo ohms. Now, 2 kilo ohm resistance is in series with another 2 kilo ohm value. Therefore, we can add them up so that another value of 4 kilo ohm is in parallel to the original 4 kilo ohm value. Now we can calculate the current through 4 kilo ohm resistance. Therefore, we can write I is equal to 4 divided by 4 plus 4 into 12. Now, because both the resistance values are 4 kilo ohms, therefore, doesn't matter whatever you put on the top, it will give you the same result. Therefore, we can write I is equal to 4 divided by 8 into 12, and we come up with a value of 6 amperes. आइए अब एक और मजीद कॉम्प्लिकेटेड मिसाल देखते हैं, जिसमें करंट सोर्स को एक साइड की बजाय नेटवर्क के दरमियान में इंसर्ट किया गया है. आइए सर्किट को देखते हैं. सर्किट शोज दैट अ करंट सोर्स ऑफ 6 amperes has been attached in the middle of two resistance values, one on each side, and another two resistances at the bottom of the current source. We want to calculate the current through 8 kilo ohm resistance, which is inside the network and is on the right hand side of the current source. To calculate the current through 8 kilo ohm resistance, we can assume that the direction of the current flow is other way round. अजीज तलबा, कभी कभी हमें करंट की वैल्यू को अपोजिट भी कंसिडर करना पड़ता है. इससे कोई फर्क नहीं पड़ता, सिवाय इसके कि एक नेगेटिव साइन का इजाफा हो जाता है, जो कि हम किसी भी वक्त करेक्ट कर सकते हैं. लिहाजा इससे घबराना नहीं चाहिए. ये हम खुद को कन्वीनियंस देने के लिए ऐसा करते हैं. नाउ the current flowing through 8 kilo ohm resistor can be calculated as I is equal to 4 divided by 12 into minus 6. You can see that we have inserted a minus sign with the total current source value of 6 amperes. Hence, the current through 8 kilo ohm resistance will be minus 2 amperes. अजीज तलबा, अगली मिसाल में हम देखेंगे कि किसी भी रेजिस्टिव नेटवर्क के अक्रॉस जब करंट सोर्स लगाई गई हो तो उसमें से किसी भी एक ब्रांच के अक्रॉस वोल्टेज को किस तरह कैलकुलेट किया जा सकता है जबकि कोई भी किसी किस्म की वोल्टेज वैल्यू मुहैया नहीं की गई हो। आइए स्लाइड पर देखते हैं। We want to calculate the voltage across 3 kilo ohm resistor. Now, if we look onto the circuit, we can clearly see that the total current, which is 1 ampere, as it reaches at the node A, it will split up. One part of the current will be flowing through 1 kilo ohm resistance and the other part will be flowing through 12 kilo ohm resistance. Further, we can see that 1 kilo ohm and 3 kilo ohm values, they are in series to each other. So, the current flowing through series combination of 1K and 3K can be calculated as I is equal to 12 divided by 4 plus 12 into 1. That will be equal to 0.75 amperes. Now, because both the resistances, that is 1K and 3K, they are attached in series, so through both of them same amount of current will be flowing. Now we can calculate the voltage across 3 kilo ohm value using Ohm's law. We can write V is equal to IR, that will be equal to 0.75 into 3K, that will be 2250 volts. इससे अगली मिसाल में हम पूरे नेटवर्क के क्रॉस वोल्टेज निकालने की कोशिश करेंगे जबकि उस नेटवर्क में सिर्फ एक करंट सोर्स लगाई गई हो। आइए स्लाइड पर देखते हैं। स्लाइड शोज अ कॉम्प्लिकेटेड सर्किट whereas only one current source has been attached with this resistive network. We want to calculate the voltage across entire circuit. That is, if we attach a voltmeter at the point A and B, then we would like to know theoretically what value of the voltage will appear onto the meter. Now, for this network, we start from the extreme left of the circuit. Clearly, we can see that 4 kilo ohm value is in series with the 14 kilo ohm value. Therefore, we add them up to get 18 kilo ohm value and replace these two resistances with an 18 kilo value. Now, this 18 kilo ohm value is in parallel with 9 kilo ohm value. Therefore, we can easily resolve the parallel combination and find out the equivalent for these two parallel resistances, so that we can write 18 kilo ohm parallel to 9 kilo ohm is equal to 18 into 9 divided by 27. That will be equal to 6 kilo ohms, and we replace those two resistances with the 6 kilo value. Once again, we can see that 6 kilo ohm resistance has become in parallel to 12 kilo ohm value. Therefore, Again we apply the parallel formula to calculate the equivalent value for two parallel resistances having values of 6 kilo ohms and 12 kilo ohms, so that we can write 6K parallel to 12K is equal to 6 into 12 divided by 18. That will be equal to 4 kilo ohms. And we replace these two resistances with the 4 kilo ohm value, which is the equivalent value. Now, we can see that this 4 kilo ohm value has become in series with the original 2 kilo ohm value. Therefore, again we can add them up to get 6 kilo ohm value and replace these two resistances with the final equivalent value of 6 kilo ohms. Now, the circuit has become extremely easy, and we can calculate easily the voltage at points A and B applying Ohm's law. That will be V is equal to IR is equal to 6. That will be equal to 6000, या फिर you can say 6 किलो वोल्ट्स. अजीज तलबा, करंट डिवाइडर में एक बात का ख्याल रखिए कि करंट को जो भी सबसे आसान रास्ता मिलता है उसी में से फ्लो करने की कोशिश करता है. मिसाल के तौर पर अगर इसे 0 ओम का रास्ता मिलेगा तो वो कभी भी 1 ओम वाले रास्ते से फ्लो नहीं करेगा. अगली मिसाल में हम इसी चीज का इयादा करेंगे कि किस तरह से जब कोई सर्किट शॉर्ट या फिर 0 ओम की रेजिस्टेंस ऑफर कर रहा हो तो करंट किस तरह से फ्लो करेगा. आइए स्लाइड पर एक सर्किट को देखते हैं. एट पॉइंट सी द करंट शुड डिवाइड इनटू 2 पार्ट्स, but because there is a short circuit between C and D, therefore no current will flow through 4 kilo ohm resistance and whole current will come at point D. जैसा कि हमने देखा कि शुरू की 2 किलो ओम वैल्यू इन सीरीज में है तो उसमें से तमाम करंट की वैल्यू फ्लो कर जाएगी. उसके बाद जो 4 किलो ओम की वैल्यू पैरेलल में अटैच की गई है, बजाय इसके कि करंट उसमें से फ्लो करे, करंट शॉर्ट सर्किट को अडॉप्ट करेगा और पॉइंट डी तक रीच कर जाएगा. इसके बाद आइए देखिए. नाउ एज वी कैन सी दैट द वैल्यू ऑफ 2 किलो ओम इज इन सीरीज, therefore total current will be flowing through 2 kilo ohm resistance, whereas no current will be flowing through 4 kilo ohm resistance. Therefore, we can easily move our current source to consider it as it is attached across the point D and the bottom of the circuit. Now, we can clearly see that the circuit has adopted a very simple form of a current divider circuit. Therefore, we apply the current division rule to calculate the current through 6 kilo ohm resistance, so that we can write I is equal to 6K divided by 12K into 1. That will be equal to 0.5 amperes. Dear students, इससे अगली मिसाल में हम देखेंगे कि अगर कोई रेजिस्टेंस करंट सोर्स के बैक साइड पे लगी हुई हो तो उसके अक्रॉस वोल्टेज को किस तरह कैलकुलेट किया जाएगा. आइए एक सर्किट लेते हैं. We want to calculate the voltage across 4 kilo ohm value of resistor. Now from the circuit, we can see that 4 kilo ohm resistor value has been attached at the back side of the current source. If it was at the front side of the current source, then there would have been no need to consider the reversal of the current. Now, because it is at the back side of the current, it will be convenient for us to calculate the value of the voltage across the resistor 4 kilo ohm. We consider the direction of the current other way round as it is shown in the circuit. Therefore, our considered value of the current flowing through the circuit will be minus 2 amperes. Hence, as it is shown in this slide, the total circuit on the left hand side of the current source has been considered discarded, and we are only left with the resistive network which is onto the right hand side of the current source. Now, the current is dividing between 3 kilo ohm and series combination of 2K and 4K. Therefore, we add the two series combinations. That will be 6 kilo ohm value, and we can calculate the current through the 6 kilo ohm value using current division rule. Therefore, by current division rule, we can write current is equal to 3K divided by 3K plus 6 kilo ohms into minus 2. Therefore, we end up with the result of 0.66 amperes. And that is the current which is flowing through the 2 kilo ohm resistance as well as through the 4 kilo ohm resistance, because they both are in series. Therefore, the current flowing through 2 kilo ohm resistance and 4 kilo ohm resistance will be the same. Hence, to calculate the voltage across 4 kilo ohm resistance, we can use the same quantity of current which will be passing through it. From Ohm's law, we can write V is equal to IR. That will be equal to 0.66 into 4 kilo ohms. That will be equal to 2640 volts. इससे अगली मिसाल में हम थोड़ा सा और शॉर्ट सर्किट पे एम्फेसिस करेंगे. आइए इस मिसाल को देखते हैं. We want to calculate the value of current through 5 kilo ohm resistor. The current should divide at point A, but due to short circuit, no current will flow through 4 kilo ohm resistor, and all the current will appear at the node B. At node B, the current divides into two parts. So, the current through 6K resistor will be I is equal to 12K divided by 6K plus 12K into 12 amperes, so that the value of I turns up as 8 amperes. At node C, which is right in the middle of the circuit, the current again finds a short circuit. All of the current will flow through it. Hence, no current is flowing through 5 kilo ohm resistance. अजीज तलबा, इस मिसाल में आपने देखा कि किस तरह से शॉर्ट सर्किट का इस्तेमाल और उसमें से करंट के फ्लो को देखा जाता है, और इस तरह से हमने देखा कि कैसे जरूरत पड़ने पर करंट की डायरेक्शन को, जो कि उसके करंट सोर्स में दिखाई गई होती है, हम उल्टी तरफ भी कंसीडर कर सकते हैं ताकि हमें कैलकुलेशंस में आसानी रहे. डियर स्टूडेंट्स, आज हमने वोल्टेज डिवाइडर की सादा और कॉम्प्लेक्स फॉर्म्स को सीखा. उसके अलावा हमने करंट डिवाइडर की मुख्तलिफ मिसालों को सीखा, जिसमें किस तरह से करंट के फ्लो को कंसीडर किया जा सकता है, यानी कि स्ट्रेट फॉरवर्ड जो डायरेक्शन करंट सोर्स की किसी सर्किट में दिखाई गई हो उसको किस तरह कंसीडर करना है, या फिर जरूरत पड़ने पर उसी करंट की डायरेक्शन को उल्टी तरफ कंसिडर करके किस तरह से कैलकुलेशन की जाएगी। अगले लेक्चर में हम करंट डिवाइडर रूल की ही मजीद कुछ और कॉम्प्लेक्स फॉर्म्स को करेंगे। उसके अलावा कर्कॉफ्स लॉ की बेसिक फॉर्म्स के बारे में भी पढ़ेंगे। करंट डिवाइडर रूल में हम ये देखेंगे कि जब किसी भी रेजिस्टेंस और किसी भी ब्रांच में फ्लो करने वाले करंट की वैल्यू दी गई हो तो किस तरह से सोर्स की वैल्यू को निकाला जाता है। आज के लेक्चर का वक्त खत्म हुआ। अगले लेक्चर तक के लिए इजाजत दीजिए। अल्लाह हाफिज।